Okay, so this question says, draw the reaction mechanism between the reactants below and predict the major product. So let's look at what we have. So first off, we have a tertiary iodine, which means we cannot have SN2 since SN2 mechanisms, they only work in primary and secondary alkyl halides. And so we also have a weak nucleophile and a weak base, because H2O can work as a base or a nucleophile, but it's weak either way. So that takes away SN2 and E2 mechanisms, because those need strong bases and nucleophiles. So now we're left with either E1 or SN1. And since this problem asks for the major product, this reaction mechanism would be SN1 rather than E1. This is because elimination reactions, they usually proceed more frequently when there's heat added. And since there's no heat, the major product will occur through an SN1 reaction mechanism. So first, in our SN1 reaction, we know that the leaving group is going to leave. So I'm going to draw this right here. So our leaving group is going to leave. So we'll have a tertiary carbocation right here. And we're going to have that iodine. That's kind of wonky, but and so with SN1 reactions, we have to be on the lookout for carbocation rearrangements. But since this is already tertiary, we don't need to worry about that. Next, our nucleophile is going to attack that carbocation. So here, I'll draw it on this side. It'll attack that carbocation. And so I'm going to draw that down here. So we'll have this water right here, and this is gonna have one lone pair, and then it'll be positive. And so we're still gonna have that iodine floating around, and since it has that negative charge, it'll be looking for a proton to take that negative charge away. So it'll attack that hydrogen, and that bond will kick back into the oxygen. And then we'll be left with this. And finally, we need to remember that in SN1 reactions, we'll have a racemic mixture. So that pretty much means we'll have two enantiomers, which one will have a dashed OH, and then the other will have a wedged OH. So that'll look like this. We'll have this, so we'll make that a wedge, and then we'll have the OH on a dash for this one. And then on the other enantiomer, we'll have this on the wedge, and then the OH will be on a dash. So that will be your SN1 reaction mechanism.